Welcome to 4.5, Graphs of Sine and Cosine Functions. We are going to talk about how you graph a variation of sine and cosine. So we're going to talk about the sine and cosine graphs today. It is a lot of information, and there are a bunch of steps, so make sure you write everything down and an explanation of what you're doing as well. So the graph of y equals sine x. So this is your standard graph of y equals sine x. So this is your standard sine graph. When x is 0, your function is 0. When x is 5 pi over 6, your function is 1/2. It is important to have this if you have not already copied it down. So some features of your sine graph. It does go on forever, so your domain is negative infinity to infinity, and the highest value, or your maximum, is 1, and your lowest is -1, so your range is -1, 1. A period, so the whole rotation, is 2 pi. So in 2 pi, in your standard sine function graph, it will make a full loop. And the function is an odd function, so if you have sine -x, it's the same as negative sine x. It does continue forever, but one full cycle is your 2 pi. So graphing of variation. Step 1 is to find the amplitude and the period. Step 2 is to find the values of x for the 5 key points, so your 3 x-intercepts, the maximum, and the minimum. So you start with the value of x that the cycle begins in your quarter period, so you want to do your period divided by 4. Since you found your period in step 1, that's fine. Step 3 is to use those values to find your 5 key points. Connect your 5 key points and then extend your graph. So amplitudes and periods. One of the graphs that we could look at is y equals a sine bx. So b has to be greater than 0. Your amplitude is the absolute value of a, and the way you find your period is 2 pi divided by b. So I have to write these down. We will be using them as we go through. So we're going to look at an example that does change your sine graph a lot, and that's okay. What we want to focus on later is when you change A, what happens, when you change B, what happens, and then there's also a C and D that we'll get to at some point. The next example does have a C, so each piece does change your graph in a different way. We're going to do one that changes it all. So the graph y equals a sine the quantity bx minus c. So it's going to shift your graph horizontally. And you have a phase shift, so that's how much it shifts it to the left or right. If c over b, which is how you find your phase shift, is greater than 0, it shifts to the right. If c over b is less than 0, it shifts to the left. And your c over b is your phase shift. So you still have your amplitude and your period. Let's do an example. So our amplitude is our absolute value of a. Well, let's look. A is our 3. B is your 2, because you have b times x, so 2 times x. And C is your pi over 3. If you remember, and go back to the other one, you have minus c, so your c comes after your negative. So our amplitude is absolute value of a, so the absolute value of 3 is just 3. In order to find your period, you have 2 pi over b. So 2 pi over 2 is just pi. So your period is pi. And then in order to find your phase shift, it's c over b. So you have pi over 3 over 2. Simplify that. So you have pi over 3 times 1/2. So pi over 6. So since this is a positive number, or it's greater than 0, it's going to move right pi over 6 units. So remember, if it's positive, it moves right. If it's negative, it moves left. So since it's positive, it's going to move right pi over 6 units. So we have our amplitude is 3, period is pi, phase shift is pi over 6. So find the values for x of your 5 key points. In order to do this, you first have to take your period and divide it by 4. So our period is pi, so pi over 4. So at x1, at my very first x, I'm going to have pi over 6. Normally, it would be 0. So normally you start at 0, but it is pi over 6 since you moved to the right pi over 6 units. x2 is going to be pi over 6 plus pi over 4. We can't just add those right away, so we have to find our common denominator, which would be 12. So you have 2 pi over 6 plus 3 pi over 4, which gives you 5 pi. Sorry, it should be 12. So you have 5 pi over 12. X to the third, now you take 5 pi over 12. So you're just adding on to see each spot where you'll be. I'm just going to do 3 pi over 12 since I know that's what I would have to go to. It's divisible by 4, so 2 pi over 3. In each case, you're just going to keep adding your 3 pi over 12. So once you get to x5, you're done. So you have your first one, which is pi over 6. x2 is 5 pi over 12. x3 we said was 2 pi over 3. x4 is 11 pi over 12. And x5 is your 7 pi over 6. Now we go on to the next part, where you plug each of those in to solve. So you will need your table of what your sine values are. So we are going to have 3 sine 2 times pi over 6 minus pi over 3. So 3 sine pi over 3 minus pi over 3. That just equals 0. So you have 3 times, you want to go back to your chart and look at what is sine of 0. Sine of 0 is just 0. So at pi over 6, you're going to be at 0. You're just going to continue down for all of them, doing the same thing. So I know pi over 3 is going to be 4 pi over 12. 6 pi over 12, this is really pi over 2. So you have 3 times whatever sine at pi over 2 is, and sine at pi over 2 is just 1. So your answer here is 3. You just keep going down. So why don't you try this one on your own, and then you can try the other 2 values. Well, 3 values. Nope, 2. Sorry. So you're going to do 3 values on your own. You're going to do 2 pi over 3, and then 11 pi over 12, and 7 pi over 6. So pause your video, solve those, and come back and check your answer. So for 2 pi over 3, you should have had it equal 0. So your point is 2 pi over 3, 0. Alright, so at 11 pi over 12, you should have negative 3. So you have the point 11 pi over 12, comma, negative 3. And then you should have 7 pi over 6, comma, 0. So if you're not sure how I did it, you can go back and check. So check your work, make sure you have everything lined up. And then the next step is you want to plot your points. So you have 5 points, and you want to plot all of them on your graph. So the red line is what just regular sine x would be at that point. And then in black you have your 3 times sine quantity 2x minus pi over 3. So your phase shift means it shifts over. It starts down at negative 3, but it shifts over. And your amplitude is 3, so it goes up 3 or down 3 from its starting point. So make sure you complete any questions below and then watch the next video. We're going to talk about cosine and cosine variation next time.